Okay, let's just jump right in here with the font rendering stuff. Okay, here in the, this is my LaserBoy folder. I got it open here, and I'm just going to go into the text folder. And in the text folder, I made a text file. You know, you right click and you can say new text document, and then name it whatever you want. And it has a .txt extension. And when you open this, by default, I think Windows wants to use Notepad, which is actually a good thing, because Notepad in Windows 10 is UTF-8 compliant. And that means it knows how to manage UTF-8 encoded ASCII strings of characters and pick out the code points, as they call them, and translate those into visible glyphs or characters that you can see in the text editor, which can be any of the standard ASCII set or beyond, which is in Cyrillic and Greek and all of the other neat glyphs that are out there. Okay, so in this example, we're going to talk about the new features, which is the UTF-8 branch of the text interpreter. Okay, LaserBoy knows how to read text files in a variety of different formats, and this keyword here, UTF-8, is the UTF-8 branch, which is new, and you'll notice that there is now a UTF-8 folder inside of the LaserBoy folder, which is now, that's new, that's a new thing. Okay, the UTF-8 branch of the text interpreter generates UTF-8 files. A UTF-8 file is a kind of report. It actually, in this case, we're calling UTF-8 branch of the text reader, and we're calling the chars function, and we're giving the chars function a file name right here of win10_Arial, and this is an example of text. We want chars to inventory this whole thing and give us a list of all the characters that are here and put them in Unicode order. Okay, so we save this as a text file. It is, in fact, win10arial.txt. So let's go ahead and open it in LaserBoy. Let's see what it does. Alright, this is the current version of LaserBoy. Check this out. If I hit Tab and I go into 1, I can choose S now, Move Menu, and it's over here. So now the main menu is here. Okay, that's new. That's kind of cool. All right, we're going to open, so that's I. We're going to open a text file, that's 4, and we know it's called win10arial.txt. So let's open that and replace the current frame set. Okay, and it says that it rendered some frames, and this says a line of text, a single line of text, and this is a nice circle kind of a thing, and I'll show you why. Back to here, into the text instructions. Okay, we did call this UTF-8 chars, so now there is a file called win10arial in the UTF-8 directory. Okay, but we also called this, which is the text branch of the LaserBoy text interpreter. See, these are all text instructions, and that's why it says a single line of text. And here's a math branch of the LaserBoy function, or the LaserBoy text reader, and so that's what rendered a circle. Actually, the reason I put those in there is because if you don't render anything into the visible frame set, LaserBoy considers that to be an error because it didn't get anything out of the text file that you can see in this space. But at the same time, it did, in fact, create, back to here, go into UTF-8, and look, we got win10arial.utf8. So let's open that. Boom. Okay. And remember, I said it's a report of sorts? Well, it is. First line of the report is a list of all the unique characters that it found in that chunk of example text that we gave it. And then here there's this dotted line thingy to designate that there's a separation here. Here's the same exact thing, except now each character has a space between them. See, it's character space, character space. There's no spaces in this at all from here to here. Okay, and then below that is kind of the report of this is what you're supposed to get if you were to turn this into a font frame set. This is your frame index, this is the glyph that you want in that frame, and this is its Unicode numeric value. And you see these are all in, and here, down here, this is exactly what we entered in for LaserBoy to examine this, to pick out all the unique characters, and it is in the same order that it appears in the text file, minus the new line characters. So it is one continuous string. The only thing that's missing between here and what we typed in to the text file is the new line characters. So, and by the way, looking back at this here, text. Okay, this like I said, you can paste anything into here. So you could go to a website and you can find, a big chunk of text that's in Cyrillic because it's one of the languages that uses Cyrillic, or it's in Georgian, or it's in Greek or something. You can copy that whole chunk of text, stick it right in here, right in this here area, and LaserBoy will, in fact, go through it, examining it as though it is a UTF-8 encoded string of characters, which it is, and pull out the individual code points and catalog them as Unicode values. So that's what that is. Now, another interesting thing is that you'll notice here is this. Okay, here's the Unicode. This is the Unicode value. In other words, this is actually in decimal, this is 33, because this character right here begins at the numeric value of 33 in an 8-bit byte. And everything below this, well, actually the one that's immediately below this, which is 20, is the space character, which is this right here. The nothing, the space character. All right, that's 20. So 21 is the first visible glyph, and it runs all the way to the end of the positive numbers that you can store in a byte. All right, this is 127 in decimal. Okay, now, that being said, another thing that you can do in the text reading part of text instructions, we have UTF-8 chars here. This is the chars function within the UTF-8 branch of the text interpreter. We have codes. So you can call the codes function, and I'm going to call the file standard ASCII. And in this case, we want the range of Unicode characters beginning at 21 hex and going to 7E hex. Range means when LaserBoy sees this word range, it says, all right, the next two tokens have to be hexadecimal numbers. This one has to be lesser than this one. And you want all the characters in Unicode from this number to this number. That's what it does. So if we go back into our our UTF-8 folder, you'll see that there is also a standard ASCII. And guess what? It looks exactly the same. Because it is the same. Right? This is all the standard ASCII characters from 21 to 7E, as you see, and so is this. The only difference is there was no actual UTF-8 text input in order to generate this. This was generated simply from the code range of 21 to 7E. All right. So there's how you get, that's one of the ways that you get this unique string of characters here. Okay, so now what to do with this? All right, here comes the fun part. Okay, now I'm going to open up Inkscape. For some reason, this takes a while. Okay. A new document. There it is. Okay. Now, we have this text tool right here, and if I select this, okay, it appears as though I can pick a font here and a weight, like whether it's normal, italic, bold, whatever, the size of the font, which we're going to crank all the way to the top, and the units of the measure is in px, which is what determines the range of these numbers here. Anyway, Okay, so then we come across here, and this is the spacing between lines, which is irrelevant because we're only going to be rendering one line of text. This is the units choice right here. And then there's this spacing here. And in spacing, one of the elements of spacing is spacing between the letters, which is when we paste a string of characters, it's how much padding it puts between each character along the line. Okay. And here we've got it set to 200, and I'll show you something that's weird about all of this. Okay. Here we have text, and we can choose text and font, which opens this panel thing over on the side here. Okay. And this is important because these two things apparently work together. The tool to drop text and this dialog over here. Okay, so we go back to our this right here, and this line where it's character and then a space and then the character and a space. We're going to select this whole thing right here and copy that. Go back to here. We've got our text tool chosen here. We drop the cursor into the page and we right click and paste. Alright, so we get this long string of ASCII characters with a space between each one. And you'll notice that, okay, this is Arial here, but you gotta look over here too, because there's this font and you gotta make sure that this lines up. Okay, because if you set it here and do stuff with it, for whatever reason, it doesn't seem to translate over to here. So you got to make sure that you choose this. We're choosing Arial here. If this had been something else, if you want to choose something else, this is really important. This apply down here, you have to do it to it. Simply choosing what you want isn't going to get it. You have to apply that choice. All right. So Arial, we're there. We'll just go ahead and say apply. So it is Arial. Now if we click on text here, this is what we pasted in, and this is live text. In other words, you can edit this and it will make changes to what is in this string right here. Okay. So we know that we're using Arial, and this is our string of text. If we go back here to spacing, see, this is what's weird. For some reason it forgets what you had when you do this, when you paste something in. So we have to go ahead and manually set this again and click somewhere else so that it reads this text field into the application and applies it. That's what it just did. And you'll notice now the characters are spaced quite far apart from each other. And here's all the characters in the standard ASCII character set in order, all in one line, okay? And is rendered as, this is going to become vector. Currently it's still true type font. You can still edit this, right? But if we go to path, this is a critical step. If you go to path, come on, path, and you choose object to path, see, this just went gray. You can't edit this anymore because this is no longer a string of text. This is now actual vector art, which when you save this as DXF, what you see is what you get. Well, while we're still looking at this though, this thing has an ultimate height. In other words, there are vectors that are sitting right along this bottom line, being the lowest y values in coordinate space, and then there's the highest y values in coordinate space. So this thing has a dimension this way. And this is a very important concept of how reading this thing works. Because LaserBoy looks at the whole thing and it says, all right, it's this high, so let's make a square out of that. We've got a window now that's 3 squares, okay? And that window that's 3 squares moves 2 squares at a time along this line from the beginning of it all the way to the end of it, moving along, and it counts the number of vertices, the number of vectors that are inside that window. And when it reaches a local maximum, the very next one, if it loses value, if there's fewer vertices, it says, all right, that was a character. And that's how it works. So now that we've done the path thing, we've done the object to path, this is now vector, and it is in fact the ASCII character set rendered in Arial. We go File, save as, and we want to make sure that we are in LaserBoy DXF folder, okay, and we choose a file type, oops, wait a minute, a file type of DXF, and this is important, revision 12, okay, so DXF R12, and we'll call it, we already have one, but we'll go ahead and call this win10 aerial.dxf, and we'll replace that file. All right, and now that's done. So now I'm going to minimize this. Okay, go back in here, and we'll open the LaserBoy application. All right. Okay, so here's LaserBoy, and now, because we saved that in the DXF folder inside of the LaserBoy folder, we can open it here. So I'm going to I to import. It's going to be number 2 for a DXF file, and we're choosing option 5, which is to replace the currently loaded frame set with an entirely new frame set that is, in fact, every font, or excuse me, every glyph in the font. We name it, it's Win10, and it's doing it, and it's done. And here it's asking me, it knows that there is a file called win10.utf8 in the utf8 folder, because when we open this file, we open the file named win10.aerial, or excuse me, win10_aerial.dxf. So it looks for the same name in the utf8 folder, and there is one, and it wants to know if we want to rename all of the frames in this frame set with the Unicode hexadecimal values of each character. And so we answer Y for yes, and it did just that. See, now this is, the name of this frame is 21, and the name of this frame is 7E, and so on. Okay, they're all named. Okay. All right, now once it's in this, once it's here, this is aerial, this is the whole thing. At least it's the standard ASCII part of it. There's some things we can do here that kind of fix this up a little bit. The way it is now, it would absolutely work. This has been saved. You want to save this right now as an ILDA frame set called Win10 Aerial and use it as a font. Save it in the fonts directory inside of the ILDA folder. It would absolutely work. But there are some things that we can do to kind of, you know, standardize it a little bit more. Included in the current distribution, if you say I to import 6 for a bitmap, 8 we want to open a bitmap into the background image. There's this font grid thing, and it's asking if we want to scale the image to fit this square, and yes we do, and there it is. All right, so we've got this, like, kind of shows you where you are in this quadrant of space, with the center line being kind of an important element of it. All right, so we can look at the whole thing. You'll see that these letters are like way off of this baseline. If you want to call this the baseline, okay. Now normally, okay, when you got a background image open like this, it's for tracing over it. So like when you, if you turn it off and you zoom way in, you know, like this, because you really want to see what's going on, you know, you're way into it, tracing stuff. See that you want the background to move with it so that you can get into the details and trace over the details. But in this case, it would be more advantageous if the background didn't move. So I added a feature. If you go into Tab menu and you go to 1, which has to do with the visual attributes of what's going on the screen, there's this option R, which is track bitmap background with the view. So if it's by default that's on for tracing things. You can zoom in and the background moves with the vector art. But if we turn it off, hitting the R key, now it's off. Okay, now we can move the camera, so to speak, without this background image changing. So if we bring this down to the baseline, now you can see that, okay, every character is now sitting on the 0 line. Okay, that's one thing we can do. All right. Another thing that's kind of interesting here is if you hit the, okay, there's the question mark and the / at the bottom of the keyboard. If you just hit the /, you get statistics for the entire frame set. There's 94 frames. All 94 of them are two-dimensional. The total, wow, that's wild. The total number of vertices in the whole set is only 2,488. Anyway, this thing, Max X 31, what that means is frame number 31 in this set has a value in it that is the closest to the boundaries of space. And it doesn't really matter whether it's going out positive side of X or the negative side of X. It's proximity to the boundaries of space. So if we hit the Y key, we can go to a frame index, and it's saying 31, so we go to 31, and it's this. That is the closest to the edge of space, all right? And also, the tallest one, or the one that's closest to the boundaries in Y, is 3, okay? So if we go Y 3, it's this one. And you can see it's right on there, okay? So basically, if we were to zoom this in, oh, wait a minute, let's go back to Y. We're gonna go to maximum X of 31. That's this thing. So if we'd use the D key to zoom in just a little bit, see, we can get dangerously close here. And then we can even shift Q, move it back like this, and D. Alright, so now we're still totally in the positive region of space with regard to the x-axis, right? And then let's go to this one, frame 3, we go Y3, and we're still good as far as the actual boundaries of space are concerned in the y-axis. So if we see here, it says little v, big V, right? Capital V means that it applies to the entire frame set. It will, whatever the camera view is right now, which is zoomed a little tiny bit, brought down like that, that view can be applied to the actual vector art itself with a Shift V. So now it's done. So now the entire frame set has been kind of zoomed and focused and brought down, so it's on the zero line. All right, so there it is. Okay, so now if we save this, we go O to output, 1 for tilde, 3 to change directories, to fonts, we're in the fonts directory, 3 to save the entire frame set to Win10 Arial. Yep, and it says there already is one, that's fine. Yes, okay, escape. Now we have this. This is Win10 Arial. It's in the fonts directory. So now, if we go back to here, okay, that's the report. Let's go back to text files. We go into our text directory. If we open up winarial.txt, remember this is the file that we used to create the Win10 Arial.utf8 in the utf8 folder. And then we used the utf8 file, which is a report of this, copied it, pasted it into Inkscape, did all that stuff, saved it as DXF, brought it into LaserBoy, saved it as a font file, so now it exists. So let's just take this same chunk of text and put a different header on it, and in this case, we're calling upon a text function. So we're saying fixed space is 1, so that means it's going to put the characters at a regular interval of 1 square along the line. The line space is 2, so the lines are going to be separated by 2 squares in height. 2 space is 95%, which means the image, whatever image that renders, it puts it in, it scales it to 95% of the square of space itself. And we're going to use the font we just made, Win10 _ Arial, and we're going to make it white. And this text fixed left is actually the instruction that renders this to here. All right? So in other words, from where we're calling it here to here is what gets rendered by this instruction. Text means it's in the text branch of the text interpreter. Fixed means that the characters will be placed at a regular interval regardless of their individual width. And left means that this chunk is left justified. Okay? So if we open this now in LaserBoy, in 4 for a text file, Win10, enter, replace the current frame set, and there it is. That's what we just made. And that's how it works.